would like to welcome you all to this webinar. My name is Simon Steuer. I'm from the Publications Office of the European Union, and I have the great pleasure to welcome today Dr. Kirell Benzi, who will present us his presentation he did last year for EU DataViz, but now in a larger extent, in an extended version, and I think this will be a very interesting presentation. Just some organizational parts in the beginning. As I told you, please mute your microphone and turn off your video so that we have a good WebEx connection. If you have any questions, put them in the chat box. And this webinar is part of a series. And we had already quite some webinars. 2 more are already available in EU Learn, and 5 more will come to EU Learn soon. So check the website. This webinar will be recorded and will be available afterwards on the YouTube channel of the Publications Office of the European Union. So in case you missed something or you would like to share it with your colleagues, please do so. It will be available as of tomorrow. With that, I would also like to mention our community of practice of data visualization. And the Publications Office started this together with the Joint Research Center. And it's a platform for EU colleagues to share their experiences in data visualization, to share best practices, to share great examples, and to know what is available. And there are already now over 500 members. And if you have any questions also to that one, you see the link now in the chat box. Please do not hesitate to put it in the chat box. We have the community manager, Inmaculada Farfan Velasco, in the chat also. And with this one, with no further ado, I would like to give the floor to Kirell. Kirell, the stage is yours.
Can you hear me okay now? So welcome everyone.
Yes.
Thank you very much for the invitation. As Simon said, this will be like a more extended version of a talk that I gave last year. And basically the topic today is can we use data art? And we're going to define what is data art to do better data visualization in general, like better communication to the audience. So this presentation is going to be a bit special. I'm not sure you're very familiar with this novel technique that I'm going to introduce. It's going to be interactive, meaning that you can join me online on this website. So if you have a phone, you can just scan the QR code, or if you're just on your browser, you can go on slido.com and enter the hashtag EUViz. And if you do so, basically with my phone, I'm going to be able to ask you some questions, for instance, this one, and you will answer, and you'll see that we will see all the results updating in real time. So just join us here on slido.com, and you will see the presentation. It has quite a few surprises relying on this mechanism. I'll try, when it's in a webinar, it's not easy. We're not in the same room, so I cannot really see your faces or anything. So I try to, give some interaction using this live polling system. So, and we see we had like some people that my life revolves around data and visualization, which is unexpected, but a nice surprise. So most people here I dabble, right? So it's perfect. I think the audience is really tailored for this, and I didn't really know about this beforehand. So that's why I wanted to have this. So you can always join, and it's going to be on the same link. So don't close your browser on your phone. And when I will update and I ask you new questions, this will basically change in real time. So you don't have to move or do anything. Okay. So without further ado, if I can get back to my screen, which seems that it's blocked. WebEx is not, usually I use Zoom. Okay, it's still that I'm stuck. So it's not very a good experience. Let me try again. If I do this, okay, now you should see. So just a bit about myself, so you have a better idea of who I am. I have a PhD in data science from EPFL. I'm a DataViz lecturer at several universities. And today, like the really important topic is that also I'm a professional data artist. And maybe you don't really know what it is, and that's fine, because we're here to talk about DataViz and the artistic data visualization, which is data art. So just to give you an idea of how I really started, it's very funny, but in short, is like, this is what when I try to, do my PhD, people were asking me, what are you working on? And this is really what I was trying to explain to them. In 5 minutes, I'm like, yeah, I'm doing this. Look at and you see all the computations. And what I didn't realize at that time is that people were asking the question just out of courtesy, right? So I was really, I would say, in too deep. And this is what we usually have to say for scientists, right? They are in their ivory tower and they have a hard time communicating. So then I realized, okay, maybe I could, I would need some DataViz, right? This could be transformed into more visual things. So I will ask you now our second question. So what do you think DataViz is? So what's the purpose of DataViz? And okay, it's just a rough answer, just to keep you entertained. Okay, we talked about communications already. Okay, we have exploration. Impress the boss. Okay, I will let you guys answer it. Okay, so we have 63, yeah, it's counting. So tons of people engaged, it's pretty good. So, okay, I would say like 92% of people okay, in communication, I was really waiting for the pretty picture, answer to see if people thought this would be the main point. But you're right. So I would say that the main point of DataViz, 3 main points, I would say. First, communication, and we're all right. You want to communicate insights from data visually, right? The second goal could be, or in conjunction with, could be exploration, right? Or you have a data set, you have no idea what's inside of it, and you want to create some charts to better understand and extract some other features, and then go back to communication. But finally, all in all, the goal of DataViz is really to develop cognition, right? To have a better understanding on the underlying data set or phenomenon, whether it's the public or for yourself if you work on DataViz directly. So this is a very small example, like a regular, like a map, some bar charts, and so forth. This is regular DataViz. So this is how I really started to learn about DataViz. And maybe if you work and you dabble, as you said in the poll, right? You use one of these tools. So you can go on Andy Kirk website, and he has I don't know, 600 different reference to other tools that exist to do DataViz. So maybe you choose one of these tools, and for instance, Tableau, you open it, you have your data set, you drag and drop stuff, and that's it, right? I do DataViz. This is what we do, right? Most of the time, we create dashboards and we present our data, and we are very happy. But one thing that I noticed is that, sometimes you lack impact. Meaning that you want to really convey a message and you want people to change, hopefully. So what people do, some people, they protest, right? They go out in the street and they try to express their ideas. Me, if you want to make someone change, you have to come with things. So maybe you are familiar with the Michael Jackson song, Man in the Mirror. Start with yourself and make a change. And this made me think, and I realized that maybe if you use art as a medium, art is deeply subjective and personal. So if you can work for someone and not for the other, but if it touches you, if you really are attracted to a piece, you can really evolve, and it makes you think, right? So maybe art, we could go away from the traditional dashboards and regular DataViz and lean towards something more artistic. But of course, we need to make sure that it would be art based on data. Otherwise, it's just art and it's too subjective. So we need something which has a grander truth. And data art, to me, is the perfect balance, because it is subjective. We have some, as we will see, design choices that are really artistic, but at the same time, it is based on a real data set, and we have a more objective truth. So yeah, maybe you have both, the best of both worlds. So if I wanted to make the parallel between DataViz and data art, I would say first and foremost, and this is really important, the first goal is not efficient communication of underlying data, it's emotion, right? So this is the emotion part. So for instance, look at this piece on the left. Maybe imagine you are in the museum or online and you see it, you are intrigued because maybe you like the colors, that the shape is weird, so you want to get closer. If you want to get closer, I already did my job. Hopefully you are attracted to the piece. Then the second part is storytelling. Storytelling is, well, I give you the story, which I will do for the next pieces, or if you read it yourself, or if you have cultural mediation, someone explaining to you what this piece is about. But all in all, at the end, if you understand the story, you understand the data set, and you have some emotion, you also develop your cognition of the underlying scientific messages. For instance, this one is based on Higgs boson discovery, and it's another way, non-threatening way, I would say, to talk about these scientific subjects without resorting to the usual dashboarding thing. So I was not the only one. When I discovered this, I was really happy. I'm doing something great. But then I realized some papers already existed on artistic DataViz, like scientific papers on like research topics. And people were saying exactly the same stuff. So last year, I wanted to have an idea of how people were perceiving some of the things that I did. So we did a very small study. We have 300 people now, which horrible pie chart, which I hate, by the way. But this is Google. This charts, not mine. Basically asking some of the questions. So you had like one data art piece with no description, and the same after the next page with the description, and we wanted to see whether or not the description of the piece would change or influence your perception of it, right? So the real meaning added on top of the aesthetics and see how it changed. So we had some great results. And what's something that's really interesting to me, that's the fact that this piece is made of real data adds something more compared to other type of visual arts. And if you count maybe, or if just you count yes, you have 77%. So this is different. It's not generative art. It's not new media art. This is something different. Data art is in between DataViz and art. But of course, you have tons of constraints when you design some data art pieces that we will see. But basically, you have to be careful because if you are too artistic, sometimes then you lose. It's too difficult to see the underlying data, and it's just an expression of art. But if you're too literal, then it becomes DataViz, and you miss the emotional aspects. So you have to basically take all these parameters into consideration, like the clustering, the techniques that you're gonna use, the different colors, the shape. Is it abstract? Is it figurative? Is it going to be a static piece, like an image? Or is it going to be animated? Is it going to be interactive? So this is very similar to with DataViz. It's almost the same process. But of course, you need to find where to twist the visual so that it becomes more artistic. So it's actually quite difficult to do. I also do some fractal art and generative art, as we will see. But I think data art is the hardest of them all because you need to be in between the science and the art. So basically my job, I would say, consists in taking some data, some code or some other means and creating pretty pictures. Go back to the original question. So I want to talk about this example first, and then it's going to be your turn and you'll see this is a surprise. So I would like to talk about the Montoyas Festival, which is one of my favorite projects overall. And this is a really big data project, right? You have 11,000 hours of video, 6,000 hours of audio, it's like 2.7 petabyte of data, which is really good. So the festival was created 54 years ago, I think. So we have tons of data to digitize and to explore, basically. So this is I will start with the DataViz and then we'll go back up to the data art part. So this is a small map that I did back in the day, or you could see the location of the different artists that came and played at the Montoyas. And you will see Montreux Jazz is in Switzerland, of course, but it's not even about jazz anymore. It's very well known worldwide. As you can see, tons of different artists came to visit. And so what you see here, each dot is an artist. The more the purple the dot is, the more connected. And the connection that you see between different artists are the musical similarity. So the musical similarity is computed by extracting for each song the number of audio features such as tempo, rhythm, harmony, chord progression, like very something that you can extract from the signal itself. And then we use some machine learning to basically create a similarity map and then link them together if they sound the same, basically. So we use that at the Montreux Jazz for song recommendation. And beware that the versions that have been played at the Montreux Jazz are completely different from the studio versions, right? So you need to develop a new set of algorithm to remove all the claps, to remove some background noise, to remove some even the sound, the acoustics of the room, which is different from what we have in the studio, of course. So this is one example. Another example of a DataViz. This is the evolution of genres, music genres, over time at the Montreux Jazz. So on the left, this is the beginning of the jazz. This is now, and as you can see, each color represents a different genre. In the middle, you have the jazz, and what you can see is that the proportion of jazz is more or less constant over time. But here, we have more and more songs that have been played at the Montreux Jazz. One reason for that is that at the beginning it was just 2 days in one room, and now before COVID, we had 3 venues for 2 weeks. So you have more people, more artists that come, and you have like 2 artists per night per room, basically. And what's really interesting is you can see the revival of some funky and disco. Every 10 years, the curator invites the Cool and the Gang. They come, they play their song, but then it's completely over. So it's really interesting to understand what's really happening in the data. And this has been used by ethnomusicologists, so people who study the origin of music and how it influenced like others and cultures, to really understand and see whether the jazz was really representative of the whole world in terms of musical genres. So this is another example, which is a bit, I would say, more artistic. It's called a stream graph in the DataViz language. So we go from regular map to stream graph to something more artistic. So basically, the picture that you saw before, and then I'm going to show you again now, it's just a simple graph of the artist of the Montreux Jazz, linked by if they played together on stage, right? So this is a concert from the 80s. This is the same concert from 93. But if an artist was like the main singer and with 2 different bands, they will be connected, right? So it's pretty simple. For instance, B.B. King came 13 times at the Montreux Jazz, each time with a different band. So we'll see that it's very, very well connected. So this is what we see here at the middle. This yellow dot that you see here is B.B. King, and he is the most connected artist of the jazz. And of course, all of them they seem to converge at the center of all the links. So what's interesting is that the artists at the center are not necessarily the most popular in terms of record sale, but they are the most popular in the Montreux Jazz because they made the most connection. So they came several times with a different band, different lineup, so they connect everyone. And of course, the music genres at the center would be geared towards jazz, blues, because the music itself invites, asks for collaboration. You want to jam with someone. And you have tons of very interesting story at the Montreux Jazz, people refusing to go on stage unless they were paid in cash, 100,000 Swiss francs. They're crazy stories about, imagine in the 70s, people are smoking drugs. It's very weird. If you go to the Montreux Jazz, maybe you have the chance to visit the chalet, and you have some of the stories they are told, which is really, really cool. So this is what the DataViz, but what we wanted to go further and to create something very immersive, like a real experience. And this is what we did. So this was in the Art Lab at EPFL and the Swiss Federal Institute of Technology. So basically, you would enter this weird-shaped dome, like a planetarium, and you would go there to experience the Montreux Jazz from the data set. And we also created this small controller that you see on the right here, basically to control and to be able to browse and navigate in 360 degrees, which is more complicated, and it's more complicated than it sounds, because when you're inside, you can basically look all around. So unfortunately, I cannot really show you the whole experience because everything is copyrighted, like the images, the sound, and so forth. They can only be played at the jazz or inside this experience. But I think you get the idea. You move the ball around. You have this fisheye effect. When you click, all the songs of the art and the videos, of course, of the artist comes up, and then you can select and listen to the 200 2,700 terabyte of data. So it's a pretty cool project with tons of different parts. Of course, the data and the streaming part is the most important, but also the visuals and then the interactions. So this is the piece. So I hope that now you have a better idea of what I mean by data art and how we can come from regular DataViz and try to transform it iteratively to come to something more artistic, but it has a bigger power of immersivity, I would say, and like interactions and so forth. So this is one example. But now I want to go to the next part of this presentation, where you are the hero. So maybe you guys remember this book, right? Or you can read and you can go up to page 33 to turn left, or 44 to turn right. So basically what I would ask you to do now is to vote to choose the piece that we're going to talk about. So for instance, the first question I'm going to ask you is to pick a shape. Right, so now you can, if you go there, we will see what you pick. So it's very democratic, right? You vote, and we'll see, according to the choice that you make, we're going to talk about each, because we cannot cover everything. I wish I could spend 5 hours with you, but we need to select. So we are, okay, the circle and triangle are fighting, square is, and I also did some kind of this interactive presentation in some other places, and depending on the demographics, you have completely different results. If you go to the US, if you go to Europe, it's going to be a different. But I think now we have a clear winner with the circle, which is always the case, like almost. So let me talk about the circle. Go back to the picture that we saw a bit earlier on the printed on the wall. And as I told you before, well, if I didn't tell you what it is, if you just look at it like this, you basically have no idea. It's very abstract. You understand that, okay, you have colors, so because it's DataViz, the artistic DataViz, it should have a meaning, right? You have dots, you have connections. What could this be? This is about, as I said, the Higgs boson discovery. But it's not exactly about the physics, it's about people talking about the Higgs boson discovery on Twitter. And what we really, so this actually, the picture was taken and put as is in a scientific paper that I did, because we studied like the evolution of a rumor over time, and Twitter is the perfect data set to do that. So basically, these like the whole data set that you see here is about retweets on the Higgs boson discovery. So how do you read it? You start here with the blue, and you see the color, the gradient of color is time. So it goes blue, then green, yellow, orange, red, purple. It rotates like this. The start of the retweets are here. So this is before the official announcement of the discovery. And so researchers are in CERN. They are already tweeting. It's not official. I'm sure they don't have the right to do so, but they are so happy that they found the Higgs boson that they start to tweet. I mean, we found it, but it's not official. So no one really retweets and answers. Here's the official announcement, and you see that it's so dense that you don't even see the points anymore, right? It's like a unified gradient. So this is very, you have, I don't know how many, in total you have 55,000 nodes, and this is just over, I think, less than a week, 4 days on the whole time span. And as you progress, two things that we can see here, we have this banana-shaped community, like cluster, and another one below. And what we realized by exploring the data is that this was really about Europeans, and this about US. Beware that the official announcement was made at 8 o'clock in the morning, CET time, so our time. But for the US, this was like in the middle of the night. But still, the event was so big, and we also had some people from the US at CERN that we still have a pretty strong community of US, even though the announcement this was like the morning. And as we progress over time, we like any rumor actually, or any phenomenon on Twitter, or in general on YouTube and so forth, every viral phenomenon at some point has a peak, and then it goes down, and then it fades, because Kim Kardashian has a new pet, so we need to tweet it again, right? But what's really interesting here is that over time, we also found this very weird community. But like 3 days later, and this is also was like worth of investigating. So what I did was try to analyze the tweets, and I realized that this came from a Brazilian newspaper that like 3 days later, had the new headline, wow, we found the Higgs boson. And because this newspaper has had 7 million followers on Twitter, it also like sparkled a whole like retweet avalanche, and people were like basically creating a new community from one source of newspaper 3 days later. So this is really interesting, and of course at the end it fades and we move on to something else. So I hope that you also have a better understanding of the pictures, but of course without my explanation, and this would be impossible to read basically. So each dot is a tweet, and they are connected if they are being retweeted, all right? So this is the example, a perfect example of data art. So it is abstract, but if you have the description of someone explaining it to you, maybe you have a better understanding now of what you see, but you would not necessarily put this as a regular database, I would say. So now we don't have time to cover the triangle and the square, I'm sorry, but we can I can ask you another question and ask you to pick a color. So you can vote on your phones right now, and we'll see which color you take. And this is really interesting. So people vote. We see what I like about this software is like you see like people are fighting each other in real time, and it's pretty good. Sometimes you also have like perfect equality, so I need to decide which is which. So now we have blue, circle and blue. Okay. Maybe some of the yellow, you know that you can actually edit your answer if you want, right? You can go yellow and you can change. But I think we are okay with blue. So let's go to blue. Usually you don't see, WebEx has like an issue. Usually you don't see the rest of the slides. So talk about blue. Okay, this one. But this one I didn't talk about it earlier. So we basically also, once again, have no idea of what this could be. But imagine you are in front of it in the museum or anything. So you want to get closer, you realize that you have thin lines, like two main colors, like blue and red, and also some yellow, but it's like very sparse. And they are very well connected at the center, and they seem to radiate outwards, right? So this piece is about ours, my favorite topic. So basically what I did was to scrape Wikipedia. So I'm not sure if you know Wikipedia, but it's actually a real, like legit website. It's the Wikipedia for Star Wars. And now there's 150,000 pages created by hand by fans. So beware that Star Wars is the biggest fictional universe ever created. And people, that's been on for like more than 40 years. So you have like TV shows, movies, of course, books, comic books, everything that we have about Star Wars is in this wiki. So what was really interesting as a scientist here was to study and to develop new tools and algorithms to try to understand this wiki, even though it's a fictional universe, because then we can take the same tools basically and apply them to our real universe, our real history. The only difference is here the data set is really clean, because it's like English, we have like hypertext links. You see here we have an info box, or like more or less well defined. If you go to Wikipedia or own your story, sometimes you have to read manuscripts in Latin, right? You have to digitize them. No one speaks Latin anymore. So you basically need to hire people. It's what they do. Huh? They hire people from the Middle East or Asia to try to decipher, just put, deciphering the letters, and then you basically take an average of what the 100 people say about this manuscript, and then you have a clean digitized version. Of course, now we try to use machine learning to understand handwriting, but it's difficult to, if you go the monks in the Middle Ages with all the calligraphy and everything, it's not that easy. So here, the data set was easier to analyze. So what did we do? We tried to connect all the characters according to their, co-occurrence. So in this Anakin Skywalker page, we have links to different other characters, and then we tried to link them to create this map of all the Star Wars characters. And this was quite popular when it was released, because it was the first time we could actually see the whole Star Wars universe. Of course, this was before the Episode 7 and all the Disney things that Disney did, which we'll not talk about here. But all in all, here, just the dots that you see, the big dots are actually the most like famous characters of the series. They're all of them, like Leia, Luke, Han, Palpatine, Darth Vader, everything. They are all at the center. Here, in the yellow dots are the criminals, because now they have a category, right? If they are blue, they are in the right side of the history. If they are red, they are in the dark side, right? So the yellow ones are in between. They have their own agenda, and they are like the criminals. And you see that Jabba the Hutt is actually one of the most connected person in the universe, even though we don't really see him in the movies. Why? Because this was expanded in the books, and don't forget that we have 40 years of people writing books about what happens after the episode 6 at the time and before. So we have a very vast and dense universe, and video games also add a ton to it. So this is my Star Wars, I would say, data set. Now, let's move on to another question. Imagine you have the Pandora's box, right? So what would you do? Would you open it or close it? Try to make some philosophical questions. And then suddenly, I think, the questions that I design are not here for nothing, right? I try to also, then I get the result that your votes, and I try to maybe at the end create another DataViz of how people answer to the question and how basically the demographics and shape their overall answers and pieces. So we have people here that are really eager to open the box, right? Let's face it, right? So, okay, let's talk about this piece then. So this piece is also, I think, is going to be of interest, especially to the publication office, because this is about connection between members of the same company, or I would say institution. In this particular case, it's a company. And the data set here was created from LinkedIn, right? So basically, you can you can ask people, GDPR, to export some of their information, which are not necessarily the emails, but unique identifiers of their connection, and try to connect members, right? So you have your connections, and anyone can go there and get a copy of your data. And you can also read the data, the archive, and try on people of the same brand or company and try to connect them. This is what I did. And it was actually a project created for a company. And what was really interesting is that so this is a very small data set. It was, I think, only 40 people, but even with 40 answers, you can reach up to 12,000 people. And what's really interesting is that, as you can see here, all this, the dots are the employees of the company, and all the rest, the end of the curve, are their connections to the outside world. And what we wanted to know here is that how many connection overlap, right? So if you work in the same company, does it mean that you have the same set of connections or professional friends? And the answer for this particular case was not at all. Actually, only 6% of people were sharing common connections, which is really interesting in terms of narrative. And then we go back to the storytelling part. So for this company, then it means that you hire people from all over the world, and each time they bring their own network and expertise. But of course, if the results were different, you could have spin it the other way and say, look, we have a very coherent structure. We all know the same one. We have the same mentality. And I think this would work maybe better if you look at employees in Silicon Valley, or there are tighter communities. But here it was in Switzerland, and it was really interesting to see that we were taking people from all over Europe, basically each of them bringing their own network. So this is another example. Now I want to talk about AI a bit, and how AI can influence the creation of new data art pieces. So I'm going to talk about something that you already know, GANs. You see it everywhere, right? You talk about deepfakes, and this is basically how it's created. You have two neural networks, and one creates a fake image from noise, and another network to check whether the image that is created is real or fake. You train it, and at the end, you can synthesize basically every image that you can imagine. So if you train it on face dataset, you can create this image, which is completely fake. And as you can see here, the earring here is a bit tells you that something is off, but I think I can find other images which are perfect. So this is really interesting if you want to make stock photos and stuff like this. Also, it opens tons of ethical questions, and this is, I'm not going to go into this debate right now, but this is really interesting as a topic. So I'm going to show you now two different like other works that I did that also are inspiring to me to go back to data art. This is what I will call AI art. So you create some artistic pieces from AI, and it's also served the same science communication narrative, because when we talk about AI, most people are really scared, right? They think of Terminator and Black Mirror. And by showing hopefully interesting aesthetics, you can also talk about what is deep neural networks, what we can use them for, and so forth. So I always have the silver lining of trying to use basically scientific techniques to talk about what's really behind the science without all the fuss and the préjugés that you have from the media or anything. So I think, sorry, we had, macro. So macro it is. So now, because it's a neural network, you can train a ton of different images. Imagine that you have 1,000 different classes, 1,000 different categories you could pick the image from. And then you can ask the network, okay, can you create an image that is a mix of several other images, right? And these are the weights. So we have 28, that's not really percentage, but the weight for gorilla is 28.28. We have some mask, we have some jellyfish. We can also remove some of the features. So, okay, now I hope that you have everything in mind and think in your head, okay, what could this be? And you have no idea because it's impossible, but it's really interesting. So this is the result. It's really funky, right? It's a mix, I would say, between some insectoid shape and also a flower. To me, this is, I call this, I think this one, Xenomorphism. It's really, to me, it reminds me of something that could, live on another planet and live like outside our solar system. It's a mix between several different shapes. And I think this is really, really interesting as a creation tool as well, because now you can, if you do concept art for like movies or video games, you can get inspired by this. But as we will see in the next slides, you can also use that to create some new DataViz. But it's just a tool that helps you get inspired, and at the same time, it has its own artistic value in itself, I think. So another example, which is a bit more complex. So here, I will ask you whether you are a sea person or a land person. And what we will see is that we have two different videos, and hopefully you have a better understanding of how we can use these GANs and neural networks to create some new inspiring shapes. Okay, so, let's say we have 60, I think, yeah. C is the winner here. So this is the video, hopefully it works. This is a YouTube video, it's called Creatures of the Deep, and we have a bit of music. So it's a small piece and made with AI. And as you can, it's much better on YouTube. It's a 4K 60 frame per second video with this oily painting feel that I really like. It reminds me of the old masters, but at the same time is not. It's completely new, right? So now we have to go out of this. So as you saw, and hopefully you can see this on YouTube, but what's really interesting is how shapes are morphing into another, and it's something that you can only do with GANs, because you can really create new, very small frames, like differences. It's not like a fade black and white, it's really morphing, growing, and going back. And this project has been also very very creative, because I also ask now concept artists, like people that draw for movies and video games, to take this image and try to, create something on their own. And then we go back to the full circle. The human, we train the machine, we get inspired by the machine, we go back to the human creativity process, and then we iterate. So just to give you an idea, this piece, this is like the final outcome. It was like displayed in Paris on the wall of this like space called EP7, so EP7. So it's pretty big, and you can imagine how this video and others were displayed in the streets. So it was actually pretty impressive, because the scale is quite big. And if you see it on YouTube, it doesn't look as impressive, of course. So this is also a key factor if you want to do data art, the ability to, have a large dedicated space or immersive experience. It could be in VR, it could be even on your screen, but the immersivity is something that we should really strive for if you really want to have a more impactful results, I would say. So yeah, this is just a small video. I'm not sure if it works. Yeah, just to see, but it was the sound is missing. The sound was created, by the way, completely tailored for this piece. And as you can see now, there's other pieces. It was actually the other choice, the land choice. So to go back to what I was saying before, you can use AI as a tool to get inspired by the generated shape. So this is, for instance, like a flower bouquet, right? And this is this is the inspired version of it, which is actually in the org chart, so an organizational chart of the company that I work for, and which belongs to the Havas group. Havas group is one of the fourth biggest communication group in the world. You have Publicis and Havas, which are two French brand. And what you see here, this is the CEO and all the connections. So you have CEO, the executive committee, and as you go up instead of down, in this particular case, you basically go down the hierarchy, right? So this is the intern of the intern, I would say. But what I really wanted to do, instead of having this very top-down hierarchical representation, what I really wanted to do is to have something more if you come and work for a company, you grow as an employee, and in technical skills and your humanity and so forth. So instead of having this, I'm the CEO and I fire you, it was the opposite. I help you grow, and you have this environment, more hopeful message. But it was inspired by some of these shapes that we saw before. So this is an example of when you zoom in, right? They are connected, and the different colors, they mean that they belong basically to the same organism, business unit or team, as we progress, as we go up. So you see, I use the AI to influence my thinking, and then to design new DataViz stuff. Now, to finish, we have 2 minutes. The core of what we do when you do data art, or even DataViz, is math. And for most people, math I hated math when I was in high school. Then I think I got lucky, and I started to get interested. I also regret not having studied enough, even though I have a PhD in data science, which seems weird, right? But now, when I discovered this, math is a constant source of wonder to me. We have tons of YouTube recording, videos talking about some interesting properties. But what I want to show you now is how you can use math to create also emotions, and how can this influence, also going back to data art, the different techniques that you can use. So something that I really like that most people know are fractal art. So this is a regular fractal, or you zoom in. This is the Mandelbrot set. And a fractal is what? It's just a shape made of parts similar to the whole in some way. So it's a very loose definition by the guy who created the fractals, basically, the official definitions. And they are really omnipresent in nature. You have this in your blood flow, leaves, crystals, vegetables, everywhere. You have fractals, mountains and so forth. Now, what people don't realize, and you can pick a side now, is that fractals are much more advanced than what we see when we have this Mandelbrot set now. Now, the tools that we develop with the invent of new computers and graphic properties are insane, and you can do really beautiful things, which doesn't look like math at all. And this is why I would like to take this point as my last point in this whole presentation, and saying science communication can also be taught with some other means that people are not really aware of. So people want to see organic fractals, right? So let's do that. This is a fractal. This is very far from what the Mandelbrot said. So of course we have this repeating patterns here that goes back, like down to infinity, I would basically. But the shape here was created just before the coronavirus. I don't know, this reminds me of a virus, but it was done a bit before, like a cell. And this is fractal, this is pure math. So you see that the power of expression is really interesting. For instance, this is a 3D fractal, which was like have a special render. So it almost looks sandy, you know, like something that was good. It's a bit dark, okay, for this one, but like a sandstorm or something like this. But this is a fractal as well. And it's very far from the usual very geometric shapes, but it's still the power of math, right? So don't discard, I mean, having to learn math and to use it in another way to talk about science communication is also very interesting to me. So now I want to show you the final piece of this presentation, which is a combination of a fractal with data. So we go back to data art. And here, the piece itself is influenced, I mean, is like moving according to the sea level of the, like given by a NASA dataset. And the camera itself goes back and forth using the tide, like the data from the tide in Bordeaux, France. So let's look at it. You see, as we go deeper, the whole shape grows because the sea level is rising. It's rising, it's rising. So we have this coral-like shape, and then when we close, like glaciers are melting, so it starts to dissolve and to turn it into something else, which expands, but could either explode and die, or if we do something else and we try to be more wary of the environment, goes back to the original regular shape. And the camera itself goes out now because it's fully. Then we go back. So the data is from like 1993 to 2018 and from the NASA Flight Center. So you see, this is a completely new way of incorporating data and narrative into like math, and basically hopefully people like it because it's different, it's non-threatening, and they learn something new. And maybe because they watch this piece, now they can, next to it you have the regular DataViz, some explanations, and hopefully they are in touch, and you can the change can come from within instead of protesting. So I think we are reaching the end of this presentation. But to finish, I would like to ask you one more question survey at the end. And basically, it's like now I've presented data art, but you can also learn it. And it's not something that is reserved to some kind of people. Anyone can learn this. And just for creativity is one of the most demanded soft skill of 2020, which I was really surprised. The first one. So people, all the jobs they have, the job description, the first one they ask is creativity. But you have some creativity workshop, but nothing is really comparable to, to go and try to make data art of your own. And so if you are interested into DataViz, that's why you're here today. I think you could be also interested in learning how to go beyond the tools that you know and try to, without coding, trying to go and create some more abstract shapes. So if you do that, you can reach out to me at the end, and you also have a mailing list, so I can send you some workshops coming up or things like this. And hopefully you had a great time. And now we'll answer any of your questions. But just to finish, I really like this quote from Georges Braque: "Art upsets, science reassures." Thank you very much for your time.
Thank you, Kirell. We have quite some questions, and thank you again for this very interactive presentation. So you might need to keep your answers short so that we can cover all of them. The first one comes from Maria. How much of your collaboration is with science and how much with art collection curators?
Most of the presentation, most of the work that I did is a collaboration between myself and scientists. So the museums are more here to display, but the real data comes from institute EPFL, France CNRs. I was in the US recently, UCI, UCLA, Stanford, things like that. So they come from scientific institutions.
Thank you. We have here a comment. It seems to me that the more arty the Viz becomes, the less intuitive it is, and a lot more effort it needs to explain it. What do you say about this comment?
Yes, it's true. This is what I said at the beginning. It's the threshold between, okay, it's too artistic. For instance, the fractal thing at the end is really leans toward the extreme data art point, right? Because what you see, you have to understand that the animation itself means something, and you basically have to take my word for it that it's actually based on the data. But at the same time, if you go back to like network visualization, just as you see here, then you can really pinpoint every point and say, okay, this point means that they are connected. So you have to find the line, and I really wanted to show you a broad scope of what you can do from like different types of data art. But it's true, you have to find the right balance.
This question here was about the discovery of the Higgs boson, and if this picture you showed us was an interactive tool, so if you could see even the tweets, or is it just
no?
An image?
So it's a question that I have regularly. So unfortunately, it's quite difficult to render like the image that you see here are the Higgs boson interactively. Why? Because you have a lot of Bezier curve load, like curved links, and the data set is pretty big. So for a browser to be able to display it interactively, you have to do quite some tricks, and most people will not be able to actually render it on their laptop. So for now, this is still a still image, and it takes time to create, because remember that the image is really big. It's like 20,000 pixels squared, so you can really zoom in and have a very big dot. But I hope that now with the technology, we can create some more interactive network stuff, like very big network, but it's not there yet.
A more organizational question, which tool did you use for this presentation?
So it's Slides.com. It's based on Reveal.js library, but I strongly suggest that we use it. The slide you can pay to the guy because it's like basically a one-man shop. And as you can see now on my screen, hopefully you can. I didn't cheat, huh? This was really an interactive presentation, and depending on your different choices, we could have lead to like different outcomes, right? So, and what I like about this tool is you can go right and left, and also down and up. So you can have the like very interesting flow.
Who is the audience of data art?
Everyone. The audience, I used it to talk to policymakers. It could be to scientists are like big fan of this, because it's really funny. You are a scientist, you know, you want to be very clean, you publish your paper, but you still need an image to get people interested into just looking at your paper. Just to give you an idea, NeurIPS conference on artificial intelligence is the most popular conference, had 12,000 submissions this year only for the papers. So it's very hard to get interested in all the papers. So having like striking images that mean something is really like a powerful way to, if you talk about it into media, right? You want people to cover your work as a scientist or as an institution and so forth. You need some striking images. Data art fits just right in.
What is your main channel of dissemination publication for your art?
I would say two. So most of my work I put online, right? This is my own, like in itself, I don't have a very strong reach, but of course, when you have like images that can be used, for instance, printed, I did some work where people were distributing it to like flyers, to and images and journals to, I don't know, 50,000 people. Of course, online, the Star Wars article stuff was quite popular in the day. It was like more than 1 million views actually. It was taken when Gizmodo, Wired, TechCrunch, and all the big media, 20 Minutes, did site. And so it's not up to me, right? I put it online. People were really interested in the story, and they started to, talk about it. And it was quite popular. It was my most, and because everyone loves Star Wars. So basically, I give you the tools, you create the image, and then you also, of course, need some of the network to push it forward. But this is exactly the same with the DataViz, right? So we have the same challenges, I would say.
What is your favorite data art visualization tool?
There's no tool. That's the bad thing about data art, and the good thing about it is that you have tools to create fractals, right? But there's no tool to make data into fractal. You have tools to do network visualization, but they're not artistic. So basically you have to either create your own tools or like take one and try to, so most of my work, I have custom Python code to read the data, manipulate it in some way. But now I'm developing a workshop in a new tool that just came out called cables.gl. It's a website. And it's web-based, and so you don't have all the tools to create data art, but you have all the tools to create interactive, beautiful visualization. And there's no coding involved. So I'm trying to really spend some time into learning this tool. It's a new way of thinking, but it's really interesting because now you can like ditch Tableau and D3 and something and try to create something more interactive, but still beautiful in the same visual.
Thank you. What is the composition of your team, and what are the profiles of the team members?
Okay, I am the one-man shop, so this is most of my work I do alone. I have a strange profile because I know the science and I also know the art, but otherwise it's a collaboration between scientists. So scientists, we discuss, they have a paper, they have their data set, and they reach out to me and we see whether we can create a piece. Otherwise, it's more like a client business work. Okay, I have a message I want to talk about. Maybe I'm wanting to launch a new product, but I have really interesting data that I really want to showcase. And then you can also reach out to me. And also, I have some other friends that can help, but most of the work is done by me.
What is the split between the design of the concept and its implementation? So, like in workload.
So, first thing you have to think when you create data art, to me, I don't have necessarily a clear idea of what I'm going to do visually because it's driven by data. So I first need to understand what's in the data. And for instance, you have this network here, and it's fully connected. So there's no like dots; they're all well connected. So if I have this network, I cannot really showcase like some patches over there because it doesn't really make sense with the data. Whereas if I go back to another pieces that we didn't see, you would see that the network itself is different, and then that you get, for instance, this one, and the data itself is completely different. So here it's going to be small patches of everything. So first you go from the data, you try to understand if you really have the same process as DataViz or data science, and then you understand and you try to make something out of this. You see, so it's different.
Yeah. And in that sense, how long does it take to develop such a DataViz art project?
It depends. It depends mostly on I would say like the visual part is not the longest. The longest is the data science part, right? So 3 weeks to 1 month, I would say in general. But for instance, this guy, this one took 8 months because this is a Wikipedia visualization, and you have like more than 5 billion visits combined over 300 million edges. And this is the data set. Then to create the final visualization that you see here, and we made a paper of this. So this was like a whole scientific process because I was not only taking the data from other scientists, I was a scientist myself. So I needed to understand what was really happening. But this is a very cool, actually one of my favorite work because of the data that you see here in Wikipedia. You can find everything on my website. So once again, it's my name, kirellbenzi.com, if you want to see more example.
Do you know if any public services are using data art in their publications?
Well, public services, for instance, maybe Frederica Pragapan. So, people reach out to other creative data visualization artists, such as Nadia Bremer, something like that, and they used it to publish. Of course, if you're a publication office, you would still need more like explanations, because if you just show that to people, they have no clue. Right? So this is where the storytelling part and the explanations. But as I was saying before, like research journals, La Recherche, I don't know, all like scientific communications. I think I saw some work in Elsevier, Nature. They also use, but of course, not a ton of people do that. So my goal also is to show what can be done, and that more people like take up this idea of data art, create their own stuff, and try to basically influence the whole scientific community and the science communication crowd to use more data art.
Some colleagues are asking how they could get started with this. Are there any tools, websites you would recommend?
Yeah, so cables would be, I think, maybe I can show it to you later. So it's called cables, like a cable.gl, for instance, is a visual tool. It's nothing is easy to start with because you need to have like a background in data, but we can, like in 3 hours, as I was saying before, have this workshop in 3 hours. You can, get creative, start to manipulate some data and create some interactive, beautiful, moving bar chart and so forth without coding, which is very it's a nice feat because most of all the things that you saw here involved at some point programming. So if you're not familiar with programming, you need to first learn how to program. It takes some time. But if you really want to get creative, you can do that with this tool called Cables. You want other tools which are more advanced. You have Touch Designer. You also have, if you want really to do 3D graphics, for instance, like this one here that I did. So it's an animation with like all the connection between cities and so forth. This was done in Houdini, so it's a tool used for VFX, visual effects, special effects. But it took me basically 1 year to learn the tool, and I'm still like a beginner, so I would not recommend this to people. This is people what they use to do any movies, like Avengers. You want to see the explosion, smoke, destruction, thing like this. But you can use it to do DataViz and data art as well.
So in the checkbox we have a discussion about who or if public administration should use data art projects, and if so, why?
So you can ask yourself the question. So you are the publication office, or you are an institution, you out release DataViz, and are there really, can you measure the impact that you have? So the number of visits, the number of even social tweets, and so forth. And are you satisfied with the impact and the influence that you're does it do anything? I'm not claiming that creating data art will change the world, but I think that it's worth discussing that maybe we should use another means of communication, especially something that is a bit more personal than regular institutional communication. When you have on LinkedIn, for instance, European Union, they put some stuff. I think going back to data art is by definition more personal and more subjective. So it would be of interest to compare the two of them, and I think to use them in conjunction. I'm not claiming that data art replaces DataViz, not at all. They work together. But not having it is just, I think, wasted opportunity.
Thank you. And with that, I would like to close and mention our next webinar will be on the 27th of November with Adina Renner, and it's called Beyond the PDF. So what could be done except PDF publication? And I think you did a great presentation, and we all like to thank you very much. And with that, we close the webinar, and enjoy your week.